Okay, so beta in last class we were discussing theorem 10. Okay, there is one and only one circle passing through three given non-collinear points, right? Today we will discuss theorem 11 R.S. Agarwal circles of any two chords of a circle so that the one which is larger is nearer to the center. It means I have explained earlier कि you can see observe the length of the chords here. What you observe? You can observe कि the chord which is nearer to the center is larger. You can see it. No? This one is larger than this, and this one is larger than this one, right? So as we are going close to the center and drawing chord, the chord is becoming larger and larger, right? That's why this theorem is saying, that is why this theorem is saying same thing. If any two chords of a circle, so that the one which is larger is nearer, means that there are two chords in the circle. Okay, let's say a chord AB and you have a chord CD, okay, and it is saying that the one which is larger, you can see that the CD is looking larger. That means CD is nearer from the center. Means the distance of CD from the center is nearer than the distance of AB from the center. Why? Because CD is greater than AB. Okay. So we have to prove it. Okay. So to prove it, first of all we will draw perpendicular from O to AB and from O to CD. Why perpendicular? Because perpendicular represents the distance, na? Perpendicular line from a point represents the distance from that point to the given line, right? So we have to show that this one is larger and this one is smaller, so the distance of this one is smaller from O to the distance of this one from the O. Okay? So what is given here? It is given that CD is greater than AB. Okay, CD is greater than AB, means the length of CD is greater than AB, and we have to show what we have to show? We have to show that CD is nearer to AB, right? So for that we will draw perpendicular, because perpendicular represents the distance, and we will show that the distance of the CD is smaller than the distance of AB. So draw perpendicular OT, okay, and similarly draw a perpendicular OS, okay. Now what we have shown? We have to show कि OS is greater than OT, right? What we have to show?
OS is greater than
Okay, beta. OS is greater than OT. Okay. By showing OS is greater than OT, we can show कि CD is nearer to the, means the distance of CD is nearer than the distance of AB. Okay. So let's see how we can show it. Join OD, okay, and OB. OD and OB. Okay, beta. The proof, we are giving proof. The proof, what we are doing, join OD and OB. Okay, join OD and OB. Now, here CD is greater than AB, right? Given. So half of CD will also be greater than half of AB, right? If CD is greater than AB, in that case, this implies that half CD will also be greater than the half AB, right? And half CD is, you can write DT, right? So in place of half CD, we can write TD. So the TD is greater than BS. Are you getting?
Yes.
TD is greater than BS. Why? We can replace half CD by TD because perpendicular from center bisects the chord. So TD is half of the CD, and similarly BS is half of the AB. So we can replace half AB by BS. Okay. So TD is greater than BS. Now we can write it. TD is greater than BS. Now look at in triangle TDO. Here OD is equals to OB. Right? Here OD is equals to OB. Right? How? OD is equals to OB. How?
OD is equals to OB, sir, because radius.
Radii. Both are the radii of same circle. So OD is equals to OB. So OD is equals to OB is equals to R. Okay. Now in triangle OTD, now we are going to calculate OT. Okay. Why OT? Because OT is representing the distance of CD from O. So we are going to find OT. Okay. And similarly we will find OS. And then we will inspect there which one is greater, OT or OS. According to theorem, OS will be greater because CD is here, CD is greater, na? So CD will be nearer and AB will be further. So in triangle OTD, we can write कि OD का square is equals to OT का square plus OT का square plus TD का square, right? Right, beta?
Yes, sir.
How?
Sir, because
OD का स्क्वायर इज इक्वल्स टू OT का स्क्वायर प्लस TD का स्क्वायर बाय पाइथागोरस थ्योरम. OD is hypotenuse. Okay. So now we have to find OT ना, तो we can write OD का स्क्वायर माइनस TD का स्क्वायर is equals to OT का स्क्वायर, right? Now you can also write it कि R का स्क्वायर, what? R का स्क्वायर माइनस TD का स्क्वायर इज इक्वल्स टू OT का स्क्वायर. ओके बेटा, तो हियर OT का स्क्वायर इज R का स्क्वायर माइनस TD का स्क्वायर, और यू कैन पुट इट इन द रूट. You can, if you want to put this, you can put this in root. You can write like this: अंडर रूट R का स्क्वायर माइनस TD का स्क्वायर इज इक्वल्स टू OT का स्क्वायर. ओके, now come in triangle OBS. Okay, in this triangle we will find OS. As you see कि in this triangle we find OT, in this triangle we will find OS. Okay, so now in triangle OBS we will apply Pythagoras theorem. In triangle OBS, OB का स्क्वायर इज इक्वल्स टू OB का स्क्वायर इज इक्वल्स टू OS का स्क्वायर प्लस BS का स्क्वायर, राइट? ओके बेटा, नाउ इन प्लेस ऑफ OB यू कैन राइट R का स्क्वायर बिकॉज OB इज इक्वल्स टू R है ना, रेडियस, माइनस वी हैव टू फाइंड OS ना, माइनस BS का स्क्वायर इज इक्वल्स टू OS स्क्वायर, और व्हाट वी कैन राइट अंडर रूट R का स्क्वायर माइनस BS का स्क्वायर इज इक्वल्स टू OS स्क्वायर, सॉरी OS, ओनली OS, राइट? Here square will not be here, right na, because we have put it in the under root, so square will not be there. Okay, so now make this equation first and this one as equation second. Okay, what do you observe from equation first and second? Yes,
P equals to radius square, which is OT minus TD square.
We observe that beta कि OT is equals to radius का स्क्वायर माइनस TD का स्क्वायर, and OS is equals to radius का स्क्वायर माइनस BS का स्क्वायर, and it is given that कि TD is greater than BS, right? TD is greater than BS, right ना? तो subtracting more from a given number, right na, OS is R square minus BS square and OT is R square minus TD square. So we are subtracting more in which case? In this case, right na? In this case we are subtracting TD square from R square. We are subtracting more from the R square, and in this case BS square, we are subtracting BS square from R square, and BS is less than TD. So we can say कि subtracting more from the same number, we are subtracting TD square from R square. Here we are subtracting BS square from the R square, but here we are subtracting more, so the subtractant means the result will be less here, na? So value of OT will be less than the value of OS. Are you getting?
Yes, sir.
Value of OT will be less than OS. Why? If someone asks why, the reason is we are subtracting more from R square here, and here we are subtracting less because TD is greater than B. So we can write by observing second and third. Okay, beta? By observing second and third. What we can say? We can say that ki OT OS is greater than OT, right? OS is greater than OT because we are subtracting more in this case from R square, and here we are subtracting less from R square. Okay. So what we can say? We can say ki chord which is larger is nearer. Here OT is less than OS, na? OT is less than OS means ki the distance of CD is less than the distance of AB, right? Okay. So let's move to the next. Theorem 12. Of any two chords of a circle, so that one which is nearer to the center is longer. Same one.
Yes, sir, same one.
And you can prove it similarly,
Yes,
as you proved the last one.
Yes, sir. Vertically.
It is just the opposite.
Yes.
The one which is the larger, the one which is the nearer, that will be larger. So you can prove it by the similar way as we proved the last one. Okay. We have already discussed this theorem. I have remembered that in the first class or maybe in the second class we have discussed these theorems. If two arcs of a congruent circle are congruent, then the corresponding. No, it is about the two congruent circles, right? We discussed in the same circle.
Yes, sir. Same circle.
Yes, we discussed this theorem in same circle. Here it is in the two different circles, but the circles are congruent. Okay. So what is the theorem? Beta, same thing will be there in this theorem also, as we have already discussed. What we have already discussed? We have discussed if there is a circle, there are two arcs. Suppose an arc AB, an arc CD. Okay. If the two arcs are congruent, means equal, the arc AB is equals to arc CD. This implies that the chord AB will equals to chord CD. We have already discussed these things in same circle. Okay, right? But here it is saying that if the two arcs of two congruent circle is the circle, two circles are said to be congruent if their radii are equal. If the radii are equal, then no matter if the circles are different or are in the same, means if the equal arcs lies in the same circle or two equal arcs lies in the two different circles but the same radius, no matter, In both the cases, the corresponding chords will be equal because the radius are equal. How we prove it? Look at here. If you have to prove कि arc AB is equal to arc CD and you have to prove कि AB is equal to CD, then how you will prove? You will join AB, OB and OA, and similarly you will join OC and OD. Okay, and you will say that this is equals to this radii, this is equals to this radii, and angle this is equals to angle this. How? Equal arc subtend equal angle at the center. So by as two triangles are congruent, and by CPCD AB is equals to CD, and similar tactics can be applied in the two different circles. You can prove two chords are equal similarly in the similar way in two different circles if the radius are equal. Look at here, AB is equals to O dash C, OB is equals to O dash C. How?
Same radius.
Radius are equal, given that OB is equals to O dash D, same radius, and here the arcs are congruent and the radius are equal. That means this angle will be equals to this. So the triangles are congruent, and by CPCT AB is equals to CD. Okay. Any theorem that you have already proved in the same circle, by similar way, if the theorem is saying कि if the same theorem is given in the two congruent circles, you can prove them by similar way, because in the case of the congruent circles the radii will be equal, and we use for same circle and for the different circles. It is matter is only for the radius. If the radius are equal, you can prove that in the same circle, and you can prove in the two congruent circles also. If two chords of a congruent circle are equal, then their corresponding arcs are congruent. By same way you can prove it. Equal chords of congruent circle equidistant from the corresponding center. All these theorems we have proved in the same circle. If you apply the same method as you had proved them in the same circle, same method you will apply here, you will get the result. Okay, because the radius are same. For example, I am going to explain another one. Equal chords of congruent circle are equidistant from the center. Means here the chords are equal and the distance from the center will be equal. Means the distance is OL and O dash M na. What is given? It is given ki it is given that कि circle radius center O and radius R है ना, and circle center O dash radius R are congruent. Are congruent. Congruent है ना, in which AB is equals to CD, and it is also given that their chords are equal, and we have to prove what we have to prove. We have to show कि OL is equals to O dash M. Theorem is that their distance is equal. So distance OL and O dash M are distance. We have to show that they are equal. How will you show? Here AB equals to CD. Given hai beta?
Yes, sir. Chord equal chords.
Equal chords given. Then half AB will be equals to half CD.
Yes, sir.
In place of half AB you can write AL.
AL
AL equals to CM. So you can see that AL is equals to CM and OA is equals to
CO.
O dash C. Why? Radius are equal and 90.
Yes, sir.
OLA is equals to angle OM O dash MC. So by right angle hypotenuse side the triangles are congruent. So by CPCT OL is equals to O dash M. Okay.
Yes, sir.
A similar way you can prove it.
Yes, sir.
Because we have already proved these theorems in one circle. And the same theorems are given in two congruent circles. So by same way you can prove them. Okay. Angle subtended by two chords are equal. Then their corresponding chords are equal. We have proved it in same circle. Now it is saying to prove it in two congruent circles. By similar way we will prove it. The way we have proved it in the same circle, but by that way we will prove it in the two different circles because the radius are the two circles are equal here. Circles are congruent, na? Now there are some examples, beta. Okay. Exercise 12A, circles, R.S. Agarwal, right? A chord of length 16 cm is drawn in a circle of radius 10 cm. Find the distance of the chord from the center of the circle. What is it? It is, if there is a circle, a chord of length 16 cm drawn in a circle of radius 10 cm. There is a circle in which there is a chord of length 16 cm. Center is O. Okay. And the length of the radius is 10 cm. It is given that the chord is 16 cm. So we can write this as 16 cm. And the radius is 10 cm. So this one is the 10 cm, right? And what it is asking for? It is asking for the distance of AB from O. So for distance we draw perpendicular line, na? So we will draw a perpendicular line. Okay? We will name it OT. Okay?
Yes, sir.
OM. We will name it OM. So OM is distance. So we have to find OM. Okay, beta? Now you can see here AB is 16 centimeter.
Yes, sir.
AB is equals to 16 centimeter. So half AB will be equals to half of 16,
Yes, sir.
that is 8 centimeter, right?
Yes, sir.
Why half AB? Because AM is half AB. The perpendicular from the center bisects the chord. When OM is perpendicular, that means ki AM is half of AB. So we can replace half of AB by AM. So AM is 8 centimeter, right?
Yes, sir.
Here AM is 8 centimeter and OA is equals to 10 centimeter. Now in triangle OAM, you will apply Pythagoras theorems, you will get the value of OM.
Yes, sir. That will be 6 centimeter.
Okay, beta?
Yes, sir.
Okay. So we should apply that, right? In triangle OAM, OA square is equals to AM square plus OM square. Okay. Now you can write OA square minus AM square is equals to OM square. Why we have done this? Because we have to find OM. That's why we are separating OM one side and transposing all the things in other side. OA is 10, 10 square, AM is 8, minus 8 square is equals to OM square. So 10 square is 100, minus 8 square is 64, so 100 minus 64, 36. And we will put it in the root, na? Because OM is square is this, so OM will be under root 36. And the value of under root 36 is equals to 6 centimeter. So we can say ki we can say ki 6 centimeter OM. Okay?
Yes, sir.
So let's move to the next question. The next question is find the length of the chord which is a distance of 3 centimeter from the circle of a radius 5 centimeter. In this case, in the first question, it is asking to find the length of distance of the chord.
Yes, sir.
And here distance is given and it is asking for length of the chord. Okay, so let's see how we will do it. Find the length of a chord which is at a distance of 3 centimeter from the center of the circle of radius 5 centimeter. So here there is a circle. Okay. In this circle there is a chord, namely AB. Okay. Center is O. So there is a chord whose distance is 3 centimeter from the center. So for distance we always draw a perpendicular line. So we will draw here a perpendicular line. Okay. OM. This is 3 centimeter. OM is 3 centimeter. Okay. Because it is given that distance is 3 centimeter and for distance we draw perpendicular line from center. Radius is 5 centimeter. We will join OA. You can join either OA or OB, no matter. OA. OA is 5 centimeter. Okay. Now what we have to find? We have to find AB. For that, first we will find AM, and AB is double of AM. Why? Because perpendicular bisects the chord. So AM is half AB. Okay? So we can find it by applying Pythagoras theorem. Right? In triangle OAM, OA square is equals to OM square plus AM square. Now OA is 5 square. 1 minute. Now we have to find AM, na? So first separate AM one side, then put values. OA square minus OM square is equals to AM square. Why we have separated AM?
Because to find the distance.
Because we have to find the value of AM. That's why we have separated it one side. So OA is 5 square. This one is 3 square is equals to AM square. 25 minus 9, 16, right? And it will come in root, because AM is square. AM will be equals to under root 16. That means 4 centimeter. AM is 4 centimeter. Okay. Then AB is equals to 2 multiply AM, right? Double of AM. 2 multiply 4, that is equals to 8 centimeter. Okay. AB is equals to 8 centimeter.
Yes, sir.
Okay, let's move to the question number 3rd. A chord of length 30 centimeter is drawn at a distance of 8 centimeter from the center of a circle. Find out the radius of the circle. It is given that a chord of length 30 centimeter means there is a circle. Let's say center is O, in which there is a chord, namely AB, length is 30 centimeter. Okay, length of the chord is 30 centimeter. The distance from the center of a circle is 8 centimeter. So for distance we draw perpendicular from the center to the chord. Let's say it is OM. So OM is 8 centimeter. Okay. What we have to find? We have to find radius. Means either OA or OB. Now we will find OA. You can take it X centimeter. So we have to find this one. Now it will be perpendicular here. So here AB is equals to 30 centimeter. Half AB is equals to half of 30 means 15 centimeter. And we can replace half AB by AM. AM is equals to 15 centimeter, right? Why we are doing this? Because beta, we can see that there is a right angle triangle OAM. And this right angle triangle, we can find its hypotenuse by applying Pythagoras theorem, and for that we should know AM and OM. That's why we are finding AM, and AM is half AB, that's why we are doing it. Okay. So AM 15 centimeter, OM is equals to 8 centimeter. It is given. Now in triangle, OAM, OA square is equals to AM square plus OM square. Here we have to find OA, so no need to transpose anything. We will put the value only. OA square AM. AM is 15 square plus OM is 8 square. After that, OA square is equals to 2 to 5. 15 square is equals to 2 to 5 plus 64. So 2 to 5 plus 64 will be equals to 289. So 289, OA will be equals to under root 289. Under root 289 is the square of 17. That means it is the 17 centimeter OA. Hence the radius is 17 centimeter. Okay. So beta, let's move to the question number 4. In a circle of radius 5 cm, AB and CD are two parallel chords of the length 8 cm and 6 cm respectively. Calculate the distance between the two chords if they are on the same side of the center and if they are the opposite side. So first we will calculate the distance for the same side of the circle, then we will calculate the distance for the opposite side of the center. What it is saying? It is saying that there is a circle. Okay, let's say its radius, the center is O. So there is a circle with center O. In that circle there are two chords of length 8 cm and 6 cm. And there are two cases. The chords are on the same side of the center and the chords are on the opposite side of the center. So we are solving for the first one. The chords are on the same side of the center. So these are the two chords, okay, AB and CD. You can see they are on the same side of the center. Can you tell me whose length will be going to be the 8 cm and whose is 6 cm?
CD will be going to be 8 cm and AB will be.
No beta, AB will be going to be the 8 cm because it is the nearer to the center, na? Nearer one is the larger.
Sir, distance or length from the chord to the center?
No, I am asking whose length will be greater, AB or CD?
AB, because it is closer.
So AB, yes. So that's why AB will take the value 8, na?
Yes, sir.
So this one will be the 8 cm and this one will be the 6 cm. This one will be the 6 cm. Okay?
Yes, sir.
Now we have to find out the distance between the two chords, right? What we have to find?
Distance.
AB, here AB is equals to 8 cm or CD, and CD is equals to 6 cm. We have to find the distance between these two chords. For distance we always draw perpendicular. So we will draw the perpendicular from center. Look at this. Okay?
Sir.
or we will mark it M and T. OM is the distance of AB from the center and OT is the distance of CD from the center. When we will subtract OM from OT, we will get TM, and TM is the distance between these two chords. TM is distance between these two chords, right? TM, this is the distance between these two chords, right? And for that we have to subtract OM from OT. So first we will find OT, then we will find OM, and we will subtract them. Then we will get TM. Okay, beta? So how we can find OT? To find OT, join OC. Okay? OC. Now CT is equals to half CD, right? So you can write that CT is equals to half CD, means CD is 6, so 6 by 3, that will be equals to 3 centimeter, right? So CT is equals to 3 centimeter and OC is equals to 5. OC is 5. Why? Because radius of the circle is 5 centimeter. It is given, है ना? Radius is 5 centimeter. Okay? So it is given that radius is 5. So we can write कि OC is equals to R is equals to 5 centimeter. वो radius है. That is 5 centimeter. Okay? So in triangle OCT, here it is 90 degree. So this one will the hypotenuse. OC का square, OC square will be equals to CT square plus OT square. As we have to find OT, we will separate OT. OC square minus CT square equals to OT square. OC is 5 square minus CT is 3 square is equals to OT square. That will be equals to 16 is equals to OT square, right? And then under root 16 equals to OT. Then it's 4 centimeter is equals to OT. Okay. Now we will find OM, na? OM is also perpendicular here. So we will find OM. We will find OM. To find OM, we will join OA. Okay. Now you can see that OAM is a right angle triangle. Okay, OAM is a right angle triangle. So now and again for finding OM, we will have to apply the Pythagoras theorem in triangle OAM, and to apply that, we first of all we will have to find AM, that is half AB. So we will write AM is half AB. AM will be equals to 8 by 2, that is equals to 4 centimeter, right? AB is 8, so AM is 4 centimeter, and OA is equals to R is equals to 5 centimeter. Okay. In triangle in triangle OAM, in triangle OAM, OAM, OA square is equals to OM square plus AM square. Now we have to find AM, so we'll transpose OM. OA square minus OM square is equals to AM square. OA is 5. 5 square minus OM is OM. We have to find OM, right? 1 minute, beta. We have to find OM, so we will not transpose OM this side. We will transpose AM this side. OA square minus AM square is equals to OM square. Okay? That will be the 5 square minus AM 4 square is equals to OM square. 25 minus 16 is equals to OM square. OM square. Now this implies that under root 9 is equals to OM, or you can say 3 centimeter is equals to OM. Now we need to find TM. So TM is equals to, we can write OT minus OM, and we can see that OT is here. OT is 4 centimeter, right? And OM is 3 centimeter. So 4 centimeter minus 3 centimeter, that will be equals to 1 centimeter. So TM is 1 centimeter, means the distance between the two chords is 1 centimeter. Okay? So the next part we will cover in next class on the opposite side of the center. Okay?